Morning students, in the previous video session we have discussed about the differential calculus, then distance and displacement. In today's video session we can go through integral calculus. So yesterday I told differential calculus we are using in mathematics, and I told if any physical quantity, if it is changing with a time, to analyze that change we are using differential calculus. For that I told about the example also about the temperature. From morning to evening temperature is changing with time. So that change we are analyzing by using differential calculus. Here integral calculus also another method, another function we are using in mathematics. In mathematics to find the area and all we are using the formulas, isn't it? So suppose if it is a regular shape, like suppose if it is a square, we know that we use the formula A is equal to L into L square. So like that formula we are using, like that for rectangle we are using A is equal to L into B. Like this for all the regular shape there is a formula to find out the area of that object. Assume that suppose you are getting on graph like this, you are drawing on graph, and in that graph you got on graph like this. So we can easily find out area under the graph. Maybe in your smaller grade you have learned about the distance time graph, velocity time graph and all, and there you have found the velocity from distance time graph, and the distance and displacement from the velocity time graph. Maybe in your smaller grade you have did this thing. Like this area under the graph we are finding. This shape is rectangle and we are using the formula A is equal to L into B formula. So for all the regular shape we can use this method. We can find the area by using formula for all the regular shape. Suppose my question is, if it is an irregular shaped object, then how we will find the area of that object? So for all the regular shape we are using the formulas, and to find out the area under the graph, or you can tell that to find out the area we are using this integration method, or you can tell integral calculus method. So what is the use of integration? Means integration is used to find out the area. Or you can tell that it is an area finding process. We know that all the geometric shape like regular shape directly we can find the area by using the formulas, but the irregular shape we can use this integration process. So integral calculus we can use the word integration. So we can use the word integration. So mostly we use this integration in our physics derivations. For example, I will show you how. Just maybe you got a graph like this. This is not a regular shape, isn't it? This is not a regular shape. Then how you will find the area? So we can use integration process. What process? Integration method we can use. So it is an area finding process, not only area, work done area, like this everything we can find out by using this integration method. So let us see how we can find out the area of this shape. So for that, what procedure we are doing means, first what you have to do means, you have to take this graph, you got a shape like this, Now this is the starting point, this is the ending point. We know that this is not a straight line, a curved line, so we need to find out the area under this graph. So you can keep initial point, final point. Now what you have to do means you have to divide this into small rectangular strip. You have to divide this into small rectangular strip. So when you are making this rectangular strip, how much a small rectangular strip you are making, that much you will get a accurate result. Now you can take this as x1, x2, x3, x4. So you see here I have divided into 4 rectangular strip. Now how you can find out the area means approximate area you can find out. You can use a function f of a. This is what delta x, delta x, delta x, delta x, delta x. Everywhere what there is a change in x. Here x1, then you can see x2, then you can see x3. So there is a change in x value, no? So you can use first start from here f of a, approximate area only I am seeing. Now you see all this area we are adding means what? We will get the total area of this. That only, for that we are using integration delta x plus f of x1 delta x plus f of x2 delta x plus f of x3 delta x plus f of x4 delta x. You see I have divided this line, this curve into 4 rectangular strip. Now if you are finding the area under this curve, if you are adding all, we will get what? We are finding the area of all these rectangular strip, we will get what? The total area. So that you see this much big step we have to do. Now what we can do is, before I told how many number of rectangular strips, still you make this rectangular strip very small, so we will get what? Very accurate result. So how much rectangular strip you are making under this curve, all this strip you have to write a formula like this, then you are adding means you will get a approximate area value. But here in integration method we are making it short by using formulas. You see how I am making a is equal to sigma, here up to 4, no? How I am making, you see n is equal to 1, here I am putting 4. Just I am showing how a formula is making by using this big formula. I am making it small. Very clearly listen, because it is very important step we use everywhere. So you see f of a starting, then what? Up to this 4 we have to find out. Now you see I am making a function f of x n delta x, because delta x is everywhere commonly. Now what is the meaning of this formula? You can read like this: sigma n is equal to 1 to 4 f of x n delta x. This means this is sigma, or you can tell summation. So f of xn means instead of this x, what we can use is, we can use this 1. So x1, then summation plus, then n is equal to 1 to 4 you can use. So you can use 1, you can use. So it will come x1 into delta x, f of x1 into delta x. Then what will come? F of x2 into delta x. Then what will come? F of x3 into delta x. Then what will come? F of x4 into delta x. This is how, this is just an example only I am showing. So here a is there, don't confuse with the data. So like this for all the x, this is starting point only. So I am making what are a formula for not for this one. This is just an example I showed. Okay, this is just an example I showed. Suppose you have a function, you are starting from x1, no? So x1, x2, x3, x4 is there. For strip you have made. So for that we are making one formula, that only. So n is equal to summation n is equal to 1 to 4 f of xn. It means instead of this n you have to give 1, 2, 3, 4. So we will get a then summation. So we are making this big formula into small. So based on this, I will show you. Assume that you have divided this curve into n number of strips. You have divided this curve into n number of strips, so that you can use the formula A is equal to summation n is equal to 1 to n f of xn dx delta x. Now you see integration formula, how much big formula I made. I will show you now. You see, function a is equal to f of, assume that you are dividing this curve into n number of strips. N number of means, you know, 1, 2, 3, 4, 5, 6, 7, 8, etc. up to n number you have divided into rectangular strip. So I made this formula, summation n is equal to 1 to n f of x and delta x. Now you see how I am writing this formula, how I made this. You see, f of xn, no? So first you have to put 1, f of x1 delta x, then summation f of, so here you have to use what? Instead of this n only we are using 1, 2, 3, 4, etc. up to n we are using. So f of x2 delta x plus f of x3 delta x plus etc. up to f of xn delta x. So this much very big formula, I am making it short. Now this is what one type of formula we are using in integration. Now another type I will tell you how. This is only most commonly we use in physics. You see, this is what this is A, this is B. So this point is A, this point is B, and in between I am making many rectangular strip, okay, many rectangular strip like this. So n number of strip, you can tell. Okay, not n number of strip, here many number made. So it is very difficult to find out of adding all the strip area. Okay, so easily what we can do is, in integration method we can use like this. A is equal to, this is integration symbol, this is integration symbol. Okay, again I am showing, this is integration symbol, again I am showing, this is integration symbol. Now you see, A is equal to integration, from where to where you have to integrate? From this point to this point I have to integrate. So A to B, how you have to tell? A to B, integration A to B. This whole what? X1, x2, x3, x4, this whole delta x, isn't it? Delta x. If you are giving limit, you can write this all into dx. Okay, so I am using the formula f of ax dx. So you see, for all the strip I am making one small formula. That is the advantage of this integration. You see, A is equal to integration integral A to B. This is the limit. From where to where? From A to B. From A to B. So from lower value is A, upper value is B. Lower limit is A, upper limit is B. So from the point A to B, I have to integrate. That means this whole portion will come under this formula. Okay, so I believe that you all understand the integration A to B f of x dx. Now you can find out the area of this curve. So you can note down this definition. What is the use of integration? It is an area finding process. For geometric shape, we can use directly find the area by using formula, isn't it? But for the irregular shape, you have to use the process of integration. Okay, now you can see in the textbook some you see Ogden is finding the same method only, area under the graph, and okay, so this thing and all you can go through. Next thing is average velocity. This is what average velocity. Average velocity, we can then you can see some small definitions. Okay, you have to learn all the definition. Maybe in the exams and all 2 mark they can ask. First one is average velocity. Definition is what? It is defined as the ratio of the displacement vector to the corresponding time interval. And the formula is very important. You have to learn all the formula. Delta r vector is equal to divided by delta t. You see, average velocity formula, V average, small v, okay, V average is equal to delta r vector by delta t. What is this delta r vector? Delta r means we know that the position vector or displacement vector. Assume that two particle, one particle is moving, one particle is moving this direction up to here, P you can keep, another particle moving Q up to here. So this is, you can take R1, this is, you can take R2 vector, R1 vector. Now you see there is a difference between these two. This difference only delta R vector I am saying. So delta R vector is equal to, you know, R2 vector minus R1 vector. This is what the position vector. Okay, so the formula is average velocity is delta R vector divided by delta T. And the definition I will show it to you. What is the definition? Average velocity is defined as the ratio of the displacement vector to the corresponding time interval. So you see, we know that the velocity formula is what? Displacement or distance by time. Here you can see, this much displacement is there. That only I am taking delta r, position vector r2 minus r1. Then average speed, average speed means what? Distance traveled by time. Distance means what? From your smaller grade we are studying ratio between the distance traveled by time. Here distance means what? Total path length is given. Okay, so distance means total path length traveled over time only distance. Okay, so average speed is defined as the ratio of total length traveled by a particle in a time interval. So yesterday I told about the distance and its definition, not total path length. That only we are saying distance and that total path length covered over for that how much time taken. That is what yesterday I shown on example also. Here 2 point A, B and covering this distance. No, this is the total path length. To cover this distance from this point to this point, this way only the object is moving. When it is moving, it takes some time, total time. That is what average speed. Average speed means it is a ratio of the total path length traveled by the particle in a time interval. Formula. So study these two definition and formula. It is very important one. Then we know that the last one is today's topic, momentum. Momentum we know already, maybe you have studied in your lower grade and all. Assume that sometimes we know momentum. I will tell you one best example. Momentum, assume that someone is driving a bike. Sometimes we are seeing what are the accidents. Sometimes the bike, a motorbike hit on a heavy bus. You can see in front of the bus also there will be some damage. Isn't it? One small motorbike is hitting on the heavy bus, but in front of the bus there will be some damage. This damage is occurring. Why it is occurring? This damage is occurring because of the strength of that. That is what we are saying, momentum. Mass into velocity. P is equal to mass into velocity. So momentum of a particle is defined as the product of mass with velocity, and its formula is P is equal to mv, and only magnitude means you can use P is equal to mv. In this formula it is writing with vector. In this formula it is just writing P is equal to mv. Okay, this thing and all you have learned your lower grade. That's what I am going little fast. This momentum, average velocity and average speed and all. And here this is also, you see, you all know that before I told. Here you can see velocity time graph. What is the use of this velocity time graph? In our smaller grade we have studied velocity time graph. We are finding what? Displacement. So this you have to study. What is the use of velocity time graph and position time graph? Position time graph means, suppose you see like this graph, if it is given velocity time means velocity time graph, and the use of this graph is to find out the distance and the displacement. So what is the use of velocity time graph? To find the distance and the displacement. The same manner, if we are using distance time graph or displacement time graph or position time graph. This type of graph we are using to find out the velocity of an object or speed you can write down. So these two things you have to know. That is what here given. And the formula we know that already we know the formula, velocity formula. Average velocity formula is delta r vector divided by delta t. That same only here also given. You can just study the definitions and the formulas. And here you have to study, in this portion you have to study what is the use of velocity time graph to find out the distance and the displacement, and what is the use of this distance time graph to find out the velocity or speed. Okay, so here many things given, so no need to go through everything. You have to know just what is the use of data and these formulas. And my dear students, all of you go through what I taught today's video. And here today's video's important point is you have to know how to do the integration. While doing the derivation and all, you will familiar with the data. It's okay, no problem. Then you study the definition for average velocity, average speed, momentum. Then you have to study what is the use of velocity time graph, what is the use of distance time graph. Thank you all. Bye bye. See you.